This video is going to cover section 1.8 regarding inverses, and it's going to cover target 1.12, that you can write the inverse equation and graph the inverse of a given function. An inverse function is a function that reverses or undoes the work of another. Let's just say I'm thinking of a number. When I double it, add 4, and divide by -5, I get 7. What is my number? Well, in order to figure this out, you actually have to apply an inverse. So you're going to start with 7, and instead of dividing by -5, you're going to multiply by -5. So you're going to work backwards in the sentence. So 7 times the -5, then the inverse of adding is subtracting, so then I'm going to subtract 4. And then it says I doubled it. That's multiplication, or multiplying by 2, and to undo multiplication, you have to divide. So the work would be 7 times the -5 minus 4 divided by 2, and the number I was thinking about was 19.5. So this process is applying an inverse. Let's start with our first example. Here it says show that each function is the inverse of the other. So we have f of x equals 3x plus 2, and g of x equals x minus 2 divided by 3. Now, to prove that they are inverses of one another, we are going to apply what we learned in section 1.7, which was composition of functions. So in A, we are going to perform f of g of x, meaning I'm going to plug x into the g function, then take my output and plug it into the f function. So when I do that, it's going to be f of x minus 2 over 3. When I plug my g function into f, it looks like this, 3 times x minus 2 over 3 plus 2. Then I get the 3's cancel out, and I get x minus 2 plus 2, which simplifies to x. So let's try the other way. If I do g of f of x, I'm going to take x, plug it into f. I get 3x plus 2. I'm going to take that and plug it into the g function. So then I get 3x minus 2 plus 2 divided by 3. When I simplify it, the x minus 2's and the minus 2 and the plus 2 cancel out, and so then I'm left with 3x over 3, which simplifies to x. And so this is just saying if f and g are inverses, then f of g of x and g of f of x are equal, and they will both equal x. Writing the equation of an inverse, and you'll notice that I have some notation here. This is f to the -1 power. It's not an exponent, it's actually f prime. And so writing the equation, there are 4 simple steps of writing the equation of an inverse. Our first step is that you want to replace f of x with y. Second step would be to interchange x and y. Step 3 is to solve for y. And then step 4 is to replace y with the f to the -1 of x. And let's do an example with those 4 steps. So let's find the inverse equation of the function f of x equals 7x minus 5. Well, the first step is that we have to replace f of x with y. So then we get y equals 7x minus 5. Our second step is to interchange our x and our y's. So we get x equals 7y minus 5. Step 3 was to solve for y, so I'm going to add 5 to both sides, and then I will divide by 7. And then the last step was to replace my y with the f prime of x. So then I get f, and it looks like to the -1 of x equals x plus 5 divided by 7. So this f to the -1 and f of x are inverses of one another. They undo the actions of the other. Example 2, it says find the inverse and state the domain and range of f of x and its inverse. So let's first start with f of x is x squared plus 1. So this is a quadratic. My domain is all real numbers, and my range is going to be greater than or equal to 1, since that's the lowest part of my parabola. That's my vertex. So step 1 was to replace my f of x with y. I'm going to interchange my x and my y, so that I get x equals y squared plus 1. Then to get y by itself, I have to subtract 1 from both sides, and then I have to take the square root. And you'll notice I did the plus and minus out in front. And then replace the y with the f to the -1 of x. And then find the domain and range. The domain now is that x has to be greater than or equal to 1. because remember we're taking the square root, everything underneath has to be 0 or positive, and then my range is all reals, and so my original function x squared plus 1 is a parabola, and its inverse is a sleeping parabola. Now I've added an example 3. It's not on your notes, but you can find some space maybe to the right of where you wrote the 4 steps. It says, what is the domain and range of f of x and its inverse? I just wanted to show you another example. So now f of x is the square root of x minus 6. So this is 1/2 of a sleeping parabola, because this is only the positive square root of x. My domain is that x has to be greater than or equal to 0, and my range is that y is greater than or equal to negative 6. So follow the steps. I'm going to replace my f of x with a y, switch my x and my y, add 6, and then I'm going to square both sides. And so then my inverse is x plus 6 squared. And now my domain is x is greater than negative 6, and my range is y is greater than or equal to 0. Now you'll notice that the inverse, x plus 6 squared, is usually a parabola, and every x value you usually can plug in. But because my original domain and range was limited, my domain and range of my inverse are also going to be limited. So if you'll notice, my domain became the range, and my range became the domain. They flip-flopped from the function. The black graph here is f of x, and its inverse is the blue graph. And so it's half of a sleeping parabola, and then the inverse is just half of a parabola. The horizontal line test. So you guys know the vertical line test when determining if a relation is a function, and now we have a horizontal line test, and this is to determine if an inverse is a function. So it says here, a function f has an inverse, that is f to the negative 1, is a function if there is no horizontal line that intersects the graph of the function at f more than 1 point. So there are 4 graphs that I have on your note sheet. I have a line, an upside down parabola, C is called a sinusoidal, and D is a cubic. So if I draw a horizontal line, these are all graphs of f of x, I know that its inverse is going to be a function if the horizontal line only hits once. So on graph A, I draw in a horizontal line, it hits once. In B, I draw a horizontal line, it hits twice. C hits more than twice, and D only hits once. So the only 2 functions that are going to have inverses that are functions is going to be choice A and choice D. Because these 2 functions hit a horizontal line more than once, I know that its inverse is not going to be a function. Graphing an inverse. In order to graph the inverse of f, you reflect it over the line y equals x, and all you really have to do is just interchange your x and your y values. So on your note sheet, if you could go ahead and graph these 3 points, 3, 0, 5, 3, and 8, 6, and then connect them with an arch, I'm going to graph its inverse. Now you notice I don't have its equation. All I'm going to do is interchange the x and the y. So 3, 0 becomes 0, 3. 5, 3 becomes 3, 5. And 8, 6 becomes 6, 8. And then when I connect them all together, you'll see that it's a reflection over the line y equals x. And the last example I have, it says the graph below is f of x, sketch its inverse and state the domain and range of each. So first of all, I have this graph. And its domain, it goes from negative 2 to 4. And its range goes from negative 1 up to a positive 3. And so what I'm going to do is interchange these points. So this point is negative 2, negative 1. So that's going to become negative 1, negative 2. Because I'm going to reflect it over the line y equals x. 0, 1 becomes 1, 0. And 4, 3 becomes 3, 4. And then if I state the domain and range of my new blue graph, the domain is now negative 1 to positive 3, and the range is negative 2 to 4. So you'll see that the domain became the range, and the range became the domain of the function and its inverse. So this video was for section 1.8 regarding inverses.